I would say majority, we'll go with 90%. Now what I was hoping to do, let's do it two ways. Actually, we can't. Who saw the vertical ones? Okay. I wonder, well, you know what, let's do it. We're gonna do it two ways. We're gonna do horizontal versus vertical.
So we're doing one of these little...
Yeah, do a template. Now my question is, because we have such a small sample, my goal was to check guys versus girls. My goal was to check guys versus girls. But no guys saw the vertical versus... You know what? Let's check it anyway. Let's check it anyway. Let's check it anyway. We'll just have two different sample sizes with a 0 in it. And we're going to run it two-tailed. Horizontal versus vertical. I want to see if there's a difference. I'm not going to pick greater or less than, just a difference. I want to see if there's a difference in the percentage of guys versus girls that saw vertical versus horizontal. See what I'm talking about here? I want to try to look to see if there's a difference in gender tied to whether we see it. Oh, wait a minute. 1, 2, 3, 4, 5.
Since no
I can't do it.
vertical
I can't do it.
Yes, you can.
I can, but I shouldn't. Not with 6. I just realized how few guys are in the room right now.
What about you?
I can't do it because I've seen the test already. It's thrown out. Let's just do it as one class. Let's just do it and realize that we can't test. It's actually a single parameter test. It's actually just a 1P. My goal, the whole point of doing this was hopefully to drive it to two genders, guys versus girls. See, there's a difference in proportion of guys versus girls, but we can't do that. So all we're going to do is, we're going to test the proportion, okay? Proportion of those who saw horizontal, because it looks like that was our largest. Looks like that was our largest chunk. Those who saw horizontal words first. Now we have a sample size of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19. And of those 19, 16 of you saw the horizontal word first. 16 out of 19. That's roughly 80%. That's roughly 80%. A little bit higher. A little bit higher. Now, we're going to test their 90% versus that. Let's see if we are any different than that 90%. Let's see if we're any different. Now, it looks like we're a little bit below. It looks like we're a little bit below. But again, when a sample as small as ours, I don't think it really matters. What's the matter?
Well, it's a totally different test than they did, because they said... Well, one
did they even do a test?
I don't know what they did.
I'm sure they didn't. It is said 90% of people. Yeah, I'm sure a test was not done.
But it's one word versus horizontal words. Is that okay with you to change that?
It's one word versus horizontal words. Oh, we can't test their hypothesis. We know right now, based on our results, we can't test it. We saw 6 people out of 19. That's a third, yes? A third is nowhere near 90%. We're not going to waste our time testing it. We're actually closer to 90% with these results. So what I'm trying to do is I'm trying to find the 90% in our results somehow. Does that make sense? I'm trying to support them somehow. I can't do it with their claim. It is said 90% will see the same word first. Well, okay, I don't believe that, but whatever. Especially based on our little results, because only 6 of us saw, our mode was 6. It wasn't 18 out of 19, which would have been like, okay, let's do that then. So, this is actually a throwback. They give us our 90%. We have a single parameter. Okay? I say we skip the errors on this. There's absolutely no need to talk about errors because they're pointless. I mean, who cares if they see the same, if we saw the same horizontal versus vertical? There's no implications for this at all. Okay? We're going back to a z distribution here. We're going back to a z distribution because we're testing our proportions. Let's find out. Let's find out if we're significantly different. 1 prop z. We're testing against 90%. 16 out of 19 of us saw horizontal words versus vertical. Let's see if there's any difference between that and 90%. Any difference? Can we claim to be any different than the 90% that they are claiming? It looks like we fall right in the interval, don't we? We're looking for a difference. There is no difference. We essentially agree with that, if you will. If you will. So I can't support their we see the same word thing. But if we redefine the variable to be the number of those, the percentage of those that see horizontal first. Dina, I like your point, Deanne. I call you Dina. Deanne, I like your point. We're actually getting away from testing what they wanted us to test. But we know if we test what they want us to test, the 90%, we know we're going to get a difference. We saw vastly below 90%. There's no reason to see that. What I wanted to see is our 16 out of 19, which is around 80%, is that different than 90? And the answer is no, it's not different than 90. It's actually pretty damn close. Now, it is different, yes. 80% is different than 90%. So since 80% is different than 90%, why did we get such a big p-value? It's a very simple reason, a throwback to something we were talking about earlier today. We only have 19 people. 19 people is hard. That's a big, fat, wide curve. You change this. You change this from 16 out of 19 to 160 out of 190, which is still 16 out of 19 as a percentage. It's the same numerical percentage. And look what happens to your p-value. All of a sudden it becomes significant. It's the same exact percentage. 160 out of 190 is the same as 16 out of 19. But it's totally different when it comes to standard error. And that's where sample size really crushes. And that's why it's always nice to have more data when we run the ones in class, because especially for proportions. Proportions just kind of fall flat on their face, unfortunately, when you have such small sample sizes. It's just a factor we have to kind of deal with. Okay? So once again, the sample size idea. Now, what if you don't have this magical 90%? This magical 90% that that this study has in front of it. Because this was a throwback. It was a throwback to a single proportion z-test. Well, here's what I want you guys to do next. Look back at your data sheet. Look back at your data sheet. I think you have to go on to page 2, side 1. Page 2, side 1. Your pick. You want to look at garlic and colds? Or do you want to look at placebos as not being placebos? Two different studies. Two different studies, exactly the same mathematics. No real need to do them both. Garlic and colds. Let's do it. Garlic and colds. Now take a look at this.